Welcome to Python Basics with EJD. Like we've been doing for several videos now, we are trying to take a tour around different Python packages for doing different tasks. In the last video, I talked about OpenCV for computer vision. So, and there I demonstrated how we can use OpenCV to work on images, on pictures, and all that, right? So if computer vision is your thing, you want to explore that the more. So here we are talking about NetworkX, or I don't know if I should call it networks for graph analysis. Interestingly, on my channel, I have a playlist on network theory, network graph and network theory. So there I use networks a lot to do some kind of network diagrams and all of that. So you want to explore, if you're interested in graph theory or network theory, you want to explore that. So, but here, this is me doing this for Python basics just to introduce the concept, just an overview. So I won't go as deeply as I went when I was actually treating graph and network theory. So if you do graph analysis, networks is a package for you or library for you in Python to get that done. So let's come here. So network for graph analysis. Uh, Introduction to networks, right? So what is networks? It's a Python library for the creation, manipulation, and analysis of complex networks. So key use cases, maybe if you want to analyze social networks, transportation networks, biological networks, citation graphs, etc. And to install it, of course, as usual, you need to use pip install networks, right? I have it installed already, so but for the sake of demonstration, that's why I'm doing this. Okay, so pip install networks. The interesting thing about about Google Colab is that the time your execution is taking, you can see it at the bottom here. So far it has taken 10 seconds. Let's see, by the time it's done, I want to see how long it takes. 14 seconds now, 15, 16. Yeah, it took about 10 seconds to install that. Well, it's not a fresh installation because I had installed it before, right? So requirements already satisfied because I have it installed. But if it's not already installed, so you can see it actually took 17 seconds. So now, for graph creation, what do you do? So for graph creation, we have basic graph types. You have undirected graphs. That's a graph where you have an arrow. You don't have any arrow showing, maybe you are joining A, B, and C. Maybe you are joining. So here, if you have A, B, and C, you're just joining A to B, A to C, and B to C like that without showing us the direction. So that's an undirected graph. But directed graphs, you have an arrow showing that, the arrow is flowing from A to B, and it is flowing from A to C, and then flowing from C to B. So that's a directed graph. So it should with an arrow. But undirected, the arrow will not be there. It's just joining the edges all around. Then we have weighted graphs with edge attributes. We have multi-graphs for parallel edges, where parallel edges are allowed, right? So for multi-graphs like that, it means that you can have you can have something flowing out of A going to B and flowing out of B going to A. So they are directed graphs with multiple edges, something like that. So then you can add nodes and edges. So adding nodes and edges now, first of all, you can create an empty graph by just saying import network X, or let me just call it networks. Import networks as NX, and then G is NX.graph, like that. So, and then you can add single or multiple nodes using G.add.node, all of this. And then you can add single and multiple edges like this also. So the nodes are actually the points like A, B, C, but the edges are maybe things like A to B, that's one, A, B is one edge, AC is another edge, BC is another edge, like that. But yeah, so importing graph data. So from edge list, importing graph data you can import from edge list, adjacency list, and dictionaries. Then you can also import graph data from built-in data sets in networks like NX.karate club graph. Okay. If you want more information on this whole thing, you can check my playlist on graph and network theory, like that. Okay, but let's see how graph creation, how does it go? So this is how it goes. So first of all, you need to import the packages. Of course, we've installed, right? So import NetworkX as NX, and then matplotlib.pyplot. This will also help us to do some plotting in this situation. Okay, so here we're just creating the graph. So we're creating an undirected graph. So we have G equals NX.graph. So if you want it to be directed, you have to make it DI graph. All right. So this is undirected now. So it's just graph. Then you can add nodes. So G add node 1, then G add nodes from, so you add node from 1 to 2, 2 to 3, and things like that. So, and then so, okay, you're adding nodes from 2, 3, 4, and 5. But then how do you add the edges now? So it means you're going to have nodes 1, 2, 3, 4, 5. This is what this one means now. But then adding the edges now. So G add edge 1, 2. So you have then add edges from 2, 3, 3, 4. So it means you're going to have an edge from 1 to 2, 2 to 3, 3 to 4, 4 to 5, and 5 to 1. Like that. So back to 1. Then you can print the nodes and the edges in that situation. So you have 1, 2, 3, 4, 5 for the nodes, and for the edges, like I said, you have 1, 2, you have 5 back to 1, you have 2 to 3, you have 3 to 4, and 4 to 5. So this is us listing out. So there are different ways of representing a graph. You can represent the graph by telling us the nodes and the edges, or you can even use only the edges to tell us this is what the graph looks like. So from this now I can draw this graph. All I just need to do is draw 5 points and then join 1 to 2, join 1 to 5, join 2 to 3, join 3 to 4, and 4 to 5, and that will be the graph. So you can actually draw the graph, or you can list the edges like this. Okay, so what about the graph traversal? I mean, I dealt with all of this in the playlist. So for graph traversal, simply talks about how you move around a graph, how you move around a network. I think that's a better way to put it. How do you move around a network? So you can have neighborhood exploration, like you can have access neighbors by you say list g dot neighbors starting from 1. Degree of a node, you talk about g dot degree 1. So I explained all this in depth in the playlist for graph and network theory. And you have traversal algorithms. So I also did, I think I did separate videos on this traversal algorithms. So you have breadth first search, So this one, I think okay, I've forgotten how. It is well explained in that playlist. It's been some time. Then there's also depth first search. So I think breadth first search is you go down the graph first and then you now start coming to the neighbors. But depth first is like you visit once you visit a node, you visit its neighbor before you move to the next place. So then applications, you can have applications and things like shortest paths, connectivity checking, and all that. So for shortest paths, you have things like Dijkstra's algorithm for weighted graphs. So you have all this. In fact, I demonstrate manually how to use the Dijkstra's algorithm or something like that. So let me check the playlist. Okay, let me check the playlist for graph and network theory. I think the cover picture is something like red, like that. So I have the playlist here now. Yeah. So I'm looking for network and graph theory network. Yeah, this is it right here. Yeah, this is it right here. So I take care of some of the introduction to graphs. So all of that is well explained. Yeah. Then I have Python codes for graphs and graph matrices. So this is where I began to talk about networks. Then graph representation and properties. I explained how to represent graphs. Just like what I said. Now you can list the adjacencies and things like that. Python code for graph properties. I did that. Handshaking lemma, Euler's theorem, and all that. We did all of that. Then 25 videos in all, because I joined both graph and network theory together. So I think we're talking about some concepts now. Yeah, I talked about the depth first search. Okay, so we have this depth first search thing going on here. So I think I gave some examples. Okay, interestingly, my pen was faulty that time, so I had to use my finger. Thankfully, I use a touch screen device, so you can see the writing is looking really weird. Uh, how was I able to do this well? Did I get the pen later? So, I mean, I explained the whole idea of depth first search and breadth first search in the next video. Then I did the Dijkstra's shortest path algorithm. I did Bellman-Ford, the Floyd-Warshall, and all of these things. Then Kruskal's algorithm and Prim's algorithm for moving around the network. So I think it was such a nice experience, even for me. Okay, so talking about the shortest path now. So we have the whole breadth first search, depth first search, and shortest path between two nodes. So BF edges, you have you have this kind of code. So if you want to learn more, you can check the playlist. So you see the BFS traversal edges. So you can see the approaches are different. So for BFS at now, you go to from 1 to 2, from 1 to 5. Then from there you can now move to 2. Then from 2 to 3. Then you can now go to 5 to 4. But in the case of depth first search, you do 1 to 2, 2 to 3, 3 to 4 before you now do 4 to 5, like that. So different approaches, and the shortest path for all of them is 154. From 1 to 4 is 154, like that. So all of that is explained properly in the graph and network theory playlist, because I actually took time to break those things down. All right, so let's talk about centrality measures. So there's an idea called centrality in network theory, right? Okay, I think I want to expand this more. So for degree centrality, there's degree centrality, which measures importance by number of connections. So how many other nodes are connected to a particular node? That's degree centrality. So to check that, you use nx.degree underscore centrality of the graph G. Then closeness centrality measures how near a node is to all others. So how near is a node to every other node? So nx.closeness underscore centrality G. Betweenness centrality measures nodes that act as bridges. So you have nx.betweenness underscore centrality of G. Then you have eigenvector centrality, importance based on connected important nodes. And this is what you use for that. And for PageRank, like what we do in Google's, that's what Google uses, right, to rank their pages. So you have Google's algorithm, which is useful for directed graphs. So it's more like in what direction, how from a particular page, how do you go to another page? That's the idea of PageRank. So in this case now, if you have degree centrality, you have dg underscore cent equals n degree underscore centrality of G. The G is that graph we had defined before. The graph that was defined previously. This is our G now. This is the first G we have here. So this is our graph defined by nodes and edges, like that. So whatever we are doing here is referring to all of that. So if you do the degree centrality, closeness centrality, betweenness centrality, eigenvector centrality, and PageRank. So using all those things we talked about just now, like this is NX PageRank of G, for PageRank, NX PageRank, eigenvector centrality, you have all of this here. So this is basically some computation going on. So talking about degree centrality now, we have one is, so for edge node 1, that's 1 0.5, 2 0.5, 3 0.5. So in fact, there's equal spread. So that graph has equal spreading, because everything is just connected by one edge or something like that, or two edges, I think. Yeah, I think it's two edges, so that's like half. That's why they are all half, I think. Then for closeness centrality now, you have, okay, it's the same thing all the way to, because the graphs are just that regular. Then PageRank, you have 0.2 for each of them. So all the nodes are like identical, so to speak, based on their centrality measures. Now we have network visualization. How do you visualize networks? This is really important too, right? So you have the basic visualization where you use Matplotlib with nx.draw, and you have options. You can check the node size, color labels, and edge thickness, and all of that you can manipulate all of that using by tweaking the numbers you find around in this code. But I mean, since I'm just introducing you to the idea, so this is it here. So that graph we've been working with, this is it right here. Okay, basic graph visualization, this is it right here. And then you can have graph visualization scaled by degree centrality. You have it right here too. Then if you want to see advanced layouts like Spring underscore layout, circular layout, shell layout, Kamada Kawaii layouts, you can also do highlighting. So you can highlighting central nodes with different colors and sizes. You can do all of that. Then you can also have a kind of interactive visualizations. So this will bring us to the idea of introduction to PyVis for browser-based interactivity. So if you want interactive networks, you need to use PyVis, right? So I'd run it before, but let me just try it again. Yeah, I think it's already, all requirements already met, so no worries. But if you're doing it for the first time, it may take a bit more time. So here now, we have installed PyVis. If not already installed, we have installed it using this. So from pyvis.network, we want to import network, and then net is network notebook is true. Net from underscore nx of G network graph. So this one now, so whatever you do here, it will now be opened like in form of a browser. Okay. I mean, we don't have the full facility for that, but that's to show you that we can actually have, apart from the basic visualization we saw up here, we can actually have some kind of interactive visualizations like that. That's the idea I'm trying to pass across with that. So applications and case studies, like we know, net we can use networks, systems for graph analysis, anything as far as you have connections, right? Like maybe we can even use it for something like family trees. How is your father connected to your uncle and things like that? So you have social network influence analysis. You can use networks. You can use it for airline routes, network shortest paths. You want to know you're flying from one place to another. What's the shortest distance you can go? Then you have citation networks and research collaboration. So you want to know for someone who collaborates with different people, what is their network like? Then disease spread modeling in epidemiology. This can also work right there. Then you have practice and exercises. So here, build a graph of friendships. You can try to build a graph of friendships among 6 students and compute their centralities. You can do that. Maybe you have some 6 friends and then you want to build a graph to network these people and compute their centrality measures, I think. Then you can visualize the shortest path between 2 airports in a flight network, right? Then you can compare breadth first search and depth first search transversal in a tree graph. But if you want more in-depth understanding of network theory and graph theory, please head over to my channel and click on playlists and look for graph and network theory. Okay, so with this, I come to the end of this introduction to networks for graph analysis. So if you work in graph theory or you work with networks, so this is the Python library, the Python package for you. All right. So thank you so much for listening. Let me know how helpful this is for you. And if there's something you'd like me to try, probably you're in a particular field and you're wondering if there's a library, a Python package, a Python library that is useful for you, just let me know. Just mention your field in the comment section, either on Facebook or on YouTube. Then I can search to see if there's a package that is in library for you. And then you want to check other videos to see if I've already treated something that deals with your area of specialization. In the next video, I'll be talking about the libraries involved in maybe geological data, right? Things that has to do with the geology like that. So watch out for that if you're into the geosciences or geography and things like that. Of course, if you have not subscribed, you want to do that right away because you'll be missing a lot if you don't do that. So why not go ahead and subscribe and be sure to hit the notification bell so you can always get alerted each time a new video is released. And having done that, you may want to take it a step further by clicking on join to become a member of the channel where you have some special privileges attached to that, right? Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing Python right. Bye.